The elements nitrogen, which is N, and chlorine, which is Cl, have the same electronegativity value, which is 3.0. Which of the following claims about the compound that forms from nitrogen and chlorine is most likely to be true? And then we have basically a multiple choice. So would the nitrogen to chlorine bond be ionic? Would the compound have the empirical formula NCl? Would the molecule of the compound have a partial positive charge on the nitrogen atom? Or will the nitrogen to chlorine bond, will it be nonpolar covalent? Okay, now they gave us some interesting pieces of information here, right? Now we know that we have a nitrogen and we have a chlorine. Now, they do say that the nitrogen and the chlorine, they have the same electronegativity value, which is 3.0 for both of them. And just know, with electronegativities, you can determine what type of bond is in that N to Cl bond, right? There's two different types of bonds. They're ionic. Well, there's more than two, but there's ionic and there's covalent, right? Are these electrons being shared? Are they being transferred? So that's what we have to figure out. Now, when you're given electronegativities, the idea here is that you can use your electronegativities to find a electronegativity difference. Because the difference between the two electronegativities will tell you what's going on with the bond. Now, since they are the same, it doesn't really matter which one you take, right? Because 3.0, a difference just means subtraction. All you're doing is you're just taking the electronegativities and you're subtracting them. So 3.0 minus 3.0, I get a big fat 0. A 0 in terms of electronegativity means that there is absolutely no attraction from an atom. No more of an attraction from an atom to the shared electrons. And that kind of makes sense. If you're both bringing the same amount of heat, nobody's really going to be winning, right? Think about it in terms of a game, right? If on the soccer pitch, right, the football field, someone's got 3, the score is basically 3-3. Did anybody win? No. Did anybody lose? No, it was a tie. So the electrons would be evenly split right down the middle. The electrons are basically the same distance away from the nitrogen as it is the chlorine. Now just know that with this type of electronegativity difference, 0, this is the lowest that you can go. This is not ionic, right? Because ionics are big. And usually with ionics, ionic is a metal plus a nonmetal. And nitrogen and chlorine, if we look on the periodic table, those are both nonmetals, so this one's out. Now, we did say that there's no pole, right? There's no winning, there's no losing, it's just a tie. And the word for pole is polarity. So if you have no pole, you basically have no polarity. This would be a non-polar bond. No pull. So let's see. Any one of these talk about being nonpolar. And I think there is one. It's the last one. The nitrogen to chlorine bond is nonpolar covalent. Covalent, by the way, just means that you have a nonmetal plus a nonmetal. And in this case, we definitely do have that, right? Nitrogen and chlorine are both nonmetals, so it falls into the category. We can't give an educated guess that the empirical formula would just be NCl. Could have had 2 nitrogens in there, could have had 5 chlorines, right? They're just talking about a single bond, but from this information given, I don't know what the whole compound is, so I don't have enough information for this. And since there was a nonpolar bond, there would be no positives and no negatives. So that's why C is incorrect as well. So I hope this helped. let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to and like the video. Just gets the word out there that this channel exists. Thank you so very much. If you want more practice like this, you can head on over to our website, glazersguide.com. The link will be in the description as well as at the end of the video, so you could head on over there if you please. There'll be tons of videos there for solutions to these types of questions. So go on, head on over. You might see questions that you might see that's on your tests and quizzes. And guess who's going to be over there? Me. Me and Andrew. So come on over, hang out with us, right? It's all cool. I'll see you on over there, and I hope you're having a great day, okay? Talk to you soon. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.